1963. A 21-year-old cosmology student at Cambridge University trips on a flight of stairs. The subsequent medical diagnosis is amyotrophic lateral sclerosis, accompanied by a grim prognosis: 2 years to live. He did not die in 1965. Instead, Stephen Hawking survived for another 55 years, fundamentally rewriting our understanding of the universe's most extreme phenomena. I am Dr. Aranya Sharma. This panel examines the mind that synthesized Einstein's relativity with quantum mechanics, all while locked inside a failing body. Joining me are theoretical physicist Dr. Hawking's earliest breakthrough tackled the very beginning of time. In the late 1960s, working alongside mathematician Roger Penrose, he applied the mathematics of black holes to the entire universe. If general relativity was correct, they proved that the universe must have begun as a singularity, a point of infinite density. By 1974, Hawking published a paper in the journal Nature titled Black Hole Explosions that shocked the physics community. He demonstrated that black holes are not completely black. Because of quantum fluctuations at the event horizon, they must emit subatomic particles. While his mind expanded to the edge of the cosmos, his physical world was shrinking rapidly. By the late 1970s, Hawking could no longer write out the complex tensor calculus required for his theories. This forced a radical adaptation in his methodology. Unable to rely on chalk and blackboards, he began visualizing complex geometric topographies entirely in his mind, manipulating multi-dimensional shapes mentally. Then, in 1985, a severe bout of pneumonia necessitated a life-saving tracheotomy, permanently severing his vocal cords. That silence was broken by an early computer program called Equalizer and a speech synthesizer built by Dennis Klatt. Operated eventually by a single cheek muscle, that distinct robotic American voice became his global trademark. It was with this painstaking 15-word-per-minute interface that he authored A Brief History of Time in 1988, a book that sold over 25 million copies. But his theoretical physics never stalled. He pushed relentlessly into the black hole information paradox. That public concession highlighted his remarkable intellectual flexibility, but he was just as fierce and impactful in the cultural sphere. Hawking fundamentally dismantled the exhausting trope of the tragic disabled genius. He insisted on experiencing weightlessness, taking a zero-gravity flight in 2007 aboard a modified Boeing 727, floating freely out of his wheelchair. Furthermore, he relentlessly used his massive global platform to campaign for accessibility, disability rights, and the preservation of the UK's National Health Service, crediting the public healthcare system with keeping him alive for decades to continue his work. He also brought a vital, subversive sense of humour to theoretical physics. For instance, he threw a glamorous party for time travelers at the University of Cambridge in 2009, complete with Krug champagne on ice. But he only mailed out the invitations after the party had already ended. No one showed up, which elegantly demonstrated his chronology protection conjecture, the idea that the laws of physics prevent macroscopic backward time travel. He maintained that rigorous scientific curiosity must be coupled with joy, even when confronting the bleakest cosmic voids or the darkest mathematical singularities. Exactly. His legacy is ultimately a testament to the sheer defiance of human consciousness. He died on March 14, 2018, fittingly both Pi Day and the anniversary of Albert Einstein's birth. He spent 55 years trapped in an unyielding physical shell, yet his mind mapped the furthest boundaries of the universe. He communicated through a single cheek muscle, yet his voice reached billions. Hawking proved that human physical limitation is merely a localized parameter, not a universal boundary condition. His life redefined what it means to be an active participant in the cosmos. The ultimate boundary condition. To summarize our key takeaways, first, Hawking forever linked quantum mechanics and general relativity by proving that black holes emit thermal radiation. Second, the devastating loss of his motor functions forced him to pioneer entirely new mental frameworks for visualizing 11-dimensional geometry without a pen or paper. And finally, he leveraged his iconic status to fundamentally normalize disability while championing global scientific literacy. Thank you, Dr. Vance and Dr. Hughes, for illuminating a mind that truly grasped the cosmos from a chair in Cambridge.